Hello guys, this is Vikesh and let's get started with today's topic, which is about recursion in Java. So let's first understand what do we mean by recursion, and then we will look at the details of the class which you are seeing on your screen. So recursion is the phenomena of a method calling itself. So we have the scenarios where we call a particular method on an object, right? But what if you have a scenario where a method wants to call itself? Now you might be wondering why a method would call itself, because this will go into an infinite loop, right? If you write a method called sum and then inside the sum method, you again invoke the sum method, then this will keep running into loops till your program goes out of memory. I will show you the example of that as well. But the basic idea is the use case where if you have a need where the method wants to call itself, that is where you will use the recursion concept. Another thing, whatever you can achieve with recursion, generally you can achieve the same output using for loops as well. But when you use it for loops, it will require you to write a lot of code. Recursion will reduce the number of lines you need to write and manage in your code. But on the other side, recursion can get a bit complex because it requires an advanced understanding of how methods actually work in Java. So before I go any further, understand that methods, whatever you define inside the method, that goes onto a stack. Remember, I covered about stacks and it's a LIFO arrangement. So whatever you define inside your method, all those variables and all those statements, they go onto a stack. And then the stack gets emptied one by one, executing the statement which is sitting on the top of the stack. That is the concept of the method execution, that under the hood it is using a stack. Now, when we talk about the recursion, it also follows the same stack insertion and stack item removal concept, that how do you insert elements into the stack and how do you remove them. So we are going to walk through an example of recursion with the help of a use case called factorial. Now, if you have studied about factorial in your school classes, you might remember that factorial is a way where, let's say, if I have to calculate the factorial of 10, then it would be 10 into the factorial of 9 into the factorial of 8 into the factorial of 7. So you see, I'm repeating the concept of calculating the factorial again and again. First, I'm calculating the factorial of 10 into factorial of 9. Then I say 9 into factorial of 8. Then I say 8 into factorial of 7. Then I say 7 into factorial of 6, and so on and so forth. So this is the concept of how do you calculate factorials. Another example where you can use recursion is a Fibonacci series. So when we talk about the Fibonacci series, the basic idea is that you sum the previous two elements, and that's how you create the next element. Then you sum the immediate previous two and you create the next element. So again, you perform the operation of summing the past two elements again and again to calculate the next element. So you see, again, you're repeating the same operation again and again. So try to identify that particular thing where you have to repeat the particular operation again and again on the whole sequence. That would be the use case where you might be needing to use a recursion concept. So here I have prepared an example for calculating the factorial of a number. So what you see on your screen is a class called complex function, and then it has a method called calculate factorial. And inside the method, you supply an argument, which is basically a number for which you want to calculate the factorial. So if you supply 5, a factorial of 5 will be calculated. If you supply 10, a factorial of 10 will be calculated. Now, the first thing which you need to do when you write a recursion function is to know the exit condition. That is probably the most important concept when you write recursion. You should know when to end the program. If you get it wrong, then your program will be stuck into an infinite loop, and it will only exit when there would be a stack overflow. Basically, there will not be enough memory inside the JVM to run your program. It will crash technically. So remember always to define a exit condition. Some people also call it as a base condition, but remember the base case or base condition or the exit condition. Either of the terms can be used interchangeably, but always remember to first define the base condition. So here, when do you end calculating the factorial? You know the factorial of 1 is 1 and it cannot go any further. So that would be your base condition, that once, if you encounter a scenario where somebody inputs 1 as an argument, then you simply return 1 because the factorial of 1 will be 1. So this is your base case. This is what is going to make sure that your program exits smoothly. If you get it wrong, your program will never end. It will go into an endless mode. Then in the else condition, you write the factorial logic based on the recursion. So like I said, what does a factorial function does is if you calculate the factorial of 5, then it would be 5 into factorial of 4, 4 into factorial of 3, 3 into factorial of 2, 2 into factorial of 1, and that's when it will end. So here I'm saying, let's say if n was 5, so you say 5 into, you again call back the same function, 5 into calculate factorial of 5 minus 1. So now again the function will be invoked with an n equal to 4. It will go here, this condition will not be met because n is 4. It will go to the else block. Again the same thing will happen, 4 into calculate factorial of 3. So you are again invoking the same function, but this time supplying n as 3. So it will go here, n will be supplied as 3. It will again check the base condition, n is still not 3, n is still not 1. So it will go to the else block. So 3 into calculate factorial of 2. It will again go up and again it will invoke the calculate factorial method, but this time with n equal to 2. This condition is still false because n is still 2. It will go to the else block and it will say 2 into calculate factorial of 1. It will again go up. This time it will invoke with n equal to 1 and it will go here and it will satisfy the condition. And that's where your program will have its first output. You remember previous execution of 5 into factorial 4 into factorial 3 into factorial 2 did not result into an output. These were the executions of the method call which were just going on the stack. So you were just, at first you had the calculate factorial of 5 on the stack. On top of it, you had the calculate factorial 4 on the stack. Then you had calculate factorial 3 on the stack. Then you had 2 and then you had 1. But when you had 1, your program did received or reached a particular end. So that was your first output. Once you have your first output ready, then you go back to the previous one. So the first statement has been popped now. You go back to the calculate factorial of 2 and you calculate that. Once you have the output of that, then you go back to calculate factorial of 3. And so you basically unpack the stack now. You basically try to remove the elements from the stack. To visualize this, this is how it will look like. That you first call the factorial 5. Let me just change the name of it just to make it look exactly how it will go on the stack. So this is how it is going to go on the stack. So you call the calculate factorial of 5, which in turn called the calculate factorial 4, which in turn called calculate factorial 3, calculate factorial 2, calculate factorial 1. And once you had the calculate factorial 1, you got the first output. And once you had the first output, then you start unpacking it because you had the value of the calculate factorial 1. So you can say 2 into calculate factorial 1's output. Calculate factorial 1's output was 1. So 2 into 1 becomes 2. And this is the output of calculate factorial 2, right? Then it goes to the next step, basically this one. And calculate factorial 3 was demonstrated as 3 into calculate factorial of 2. So 3 into calculate factorial of 2, which is this one, 2. So this gets replaced here 2 and you get the output as 6. Now you have this one also resolved. The next one on the stack was calculate factorial of 4, which was written as 4 into calculate factorial of 3. So 4 into calculate factorial of 3's output. So this function calls output. This function's call output was 6. It goes back and it says 4 into 6, 24. And you have this one also calculated. Now you go to the last statement, which was calculate factorial of 5, which was written as 5 into calculate factorial of 4. And calculate factorial of 4 has been already computed as 24. So now you can simply say 5 into 24, which is the output of calculate factorial 4. And you get the output as 120. And this is the final return statement which will be returned to you. So if you try to understand this, till this particular point, you were just calling function after function after function with a different value of n. And everything started getting into a result due to the base condition. This was the base condition. And that's why the base condition is very important. Now imagine there was no base condition. Then this would never return and it will keep calling calculate factorial, and it will keep going down the stairs. it will never be able to come up because there is no base condition. And that's why base condition is very important. At the same time, also understanding how recursion works is also very important. Always remember that the output of the first execution gets supplied in the second execution. The output of the second execution gets supplied in the third execution, and that's how the stack unpacks or empties itself. So here I'm just doing the normal drill here where I'm saying complex function equal to new complex function, and then calling the calculate factorial method, passing 5 to it, and then printing the eventual result. And if I run this, I get the output as 120, which I just walked you through. So remember how to use the recursion, why to use the recursion, how to define the base condition. All of these things will be of very much importance when you try to implement recursions. Practice this a lot. Recursion is a concept which takes time to get used to. So practice many different examples and many questions of recursion, and you will be more confident about it. Read more about this concept in the Java docs. Look at different examples on the internet. That will help you build more knowledge around this. And that's all I want to cover in this particular session. If you like this video, a thumbs up would be massively appreciated. Thank you, and we'll meet again in the next session.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.